Pre-Calculus Exam 2 Preparation Problems. Question 1. Graph of the functions shown above. Find the domain and range of the function. Express the domain and range in interval notation. Let's think about this. First, the domain of a function is all the possible x values. So for each point on the graph, you have to think about the x value, which is left or right. So over here would be x equal to 0. As you go here, it goes to 1, 2, and then all the way to 4. Now, you do see that there's a hole at 2, meaning that if you think about it, 2 is not part of the domain. 2 is not a value that you're allowed to plug in. Okay, and then all the way up to 4 you're allowed, and you can also plug in -1. -2 is okay because although you have an open circle here, there's a closed circle here, so the actual value of the function follows this closed circle. And then -3 and -4 is not okay, but any number that's getting closer and closer to -4 is okay. So you can see that -4 is an open circle, and any number getting closer to -4 is okay. Alright, so if you draw this on the number line, a nice tip is to draw the number line whenever you're being asked to write in interval notation, because once you draw it in number line, then it's clear to see what the interval is. It's like open here, then there's another open here, and there's a closed here. So that's the domain, and the domain is made up of these two intervals. The first interval is what? The first interval is from -4 to 2, not including the endpoints. Whenever you don't include the endpoints, you put round brackets. Now the second interval is from 2 to 4. Again, 2 is not included, however 4 is included. And if you have more than one interval, you put unions between them. So that's the domain. Okay, let's do something similar for the range. For the range is the y value, right? So here again, the y value is 0, and then it goes, well, it doesn't go up till 1, but it does reach 1 here. So I do see that there's a y equal to 0, there's y equal to 1, y equal to 2, 3, all the way up to 4. Everything's included. And it even goes down to -1. So just looking at this portion of the graph, I do see that everything from -1 up till +4 is included in the range. But then there's a blank space between -1 and -2. So for example, no y value is produced by this function of the value -1.5. There's nothing that produces -1.5, 1.1, or -1.9. However, starting from -2, the function does produce a -2, so -2 is included. And then it goes down -3 all the way up till -4, but stopping just before -4. So at -4 you have an open circle. Okay, so that's what you have. So if you just draw what we have, it's like open circle here, and then there's a closed circle here, there's a closed circle here, and another closed circle here. And that's our range. That's the y value. Let's write down the range then. The range would be one interval is, this is closed. One interval is from -4 to -2, including -2. Another interval is from -1 to 4, including both ends. It's important that you put these square brackets, and then you put a union between them. So that's the answer to part A. Let's look at the next question. Find the values of f0, f2, f -4, and f of 4. Okay. So let's see. F of 0, well, this point here has the coordinate 0, 0, and that means when x is 0, y is 0. So when x value is 0, your y value is going to be 0. What about f of 2? Well, if you go to 2, although you do seem to have a value 2, 0, but that's an open circle, meaning that the graph actually is not there. There's nothing at 2. So in this case, you say f of 2 is undefined. There's no value for it. Okay? And you can see this in the domain too. See, the domain excludes 2, so when you try to evaluate f of 2, that's undefined. Same thing for f of -4. f of -4 here is undefined because there's a open circle there. But f of 4, if you look at it, f of 4, there's a closed circle, so 4, 4, right? So f of 4 is the value of 4. Now I want to add one more thing, although it's not in the question. An interesting question that could be on the exam is about questioning like f of -2. What's f of -2? Well, there's an open circle here and the closed circle here. Well, the closed circle actually is the value of the function. So in this case, it's f of -2 is -2. Just by coincidence, x and y values here seems to be same, but that's not always the case. So for example, if you have a question like what's f of 1, f of 1 will be -1 because the coordinate is 1, -1. Okay, so f of 1 is -1. So these are some extra questions I added just so that you understand what's going on. Okay. All right. Find the intercepts. What's an intercept? Intercept is where the graph crosses the axis, right? This 2, 0 seems to be an intercept, but it's not an intercept because there is no portion of the graph there. So if you look at this graph, the only point where the graph crosses x or y axis is at the origin, right? So 0, 0. Okay. Ordered pair means it's asking for a full coordinate. So for C, you need to answer as 0, 0. Next question. Explain how the graph of y equals to negative radical x minus 3 minus 4 can be obtained from the graph of y equals to radical x. Okay. So you start from y equal to radical x, and there are actually more than one way to do this. So let me explain two different ways to answer A. So you can first think of this as think of applying this minus first. So if you look at the difference between y equal to square root of x and y equals to this complicated function, there's this minus, which there's no minus here, there's a minus here, and then there's a minus 3 minus 4. So it's actually two things, okay? So you can first think about putting that minus in, and then putting that minus 3 minus 4. Okay. Now this first operation is a reflection over x-axis, because you see, if you put a minus in front of the graph, you end up making the graph go upside down over the x-axis. And then this replacing x by x minus 3 shifts graph 3 to the right. 3 to the right, and then subtracting 4 makes it 4 down. Okay. So I've expressed the transformation from the original y equal to square root of x to this complicated one as a combination of the following operations. You first reflect over the x-axis, and then shift 3 right, and then 4 down. Now you could actually reverse this process and still get the same answer. Now be careful, it's not always true that you can reverse two transformations and end up getting the same thing. Sometimes the order of transformations do matter, so you really have to do the transformation, apply them, and see what's going on. Okay, so I can first take y equal to square root of x as a shift 3 right, 4 down, and that makes it as y equals to square root of x. Yeah, sorry. It actually produces different things. So we'll try to write it like this, and then we'll modify. Okay. All right. So shift 3 right and 4 down, which is this, and then you reflect over x-axis, which is putting negative to the entire thing, right? Actually, that shouldn't be it. I need minus 4. So that this is negative square root of x minus 3 plus 4. You see this? Plus 4, that's not the same as this. So before putting the minus, you really need to put a plus there. So that when you put the minus, it becomes a minus. Now, what does this plus mean? It means it's not down, it's up. Okay. So I'm giving you these two possible answers to part A. So part A could be answered in the following format. Either you can say reflect over x and translation, shifting means translation, 3 to the right, 4 down. Okay, so that's the combination of transformation you can write. You don't have to write it like this. You can actually write all of these in words. Okay, this is just a simple, compact way of writing. Small r means reflection. Capital T means translation, which is same thing as shifting. Okay. So this is one possible answer, and I would suggest that this is the easiest one. But if you want to translate first, and then you want to do the reflection, then that amounts to saying that first translate 3 right, 4 up, and then reflect over x-axis. That's another possible answer. Okay. Now, I guess the rule of the thumb is you go outside in. So if you see a minus, you do that first, and then you see something like this minus 3, then you do that next. I think that's an easy way to identify the transformations. That way of doing things will bring you to this first answer, which is easier. Okay, the second question says, draw the graph on the same graph. So first, y equals to square root of x is something that you have to remember. That's y equals to square root of x. Now, when you flip this, you're going to end up with, let's see, this, which will be y equals to negative square root of x. And then this is what is needed to be shifted 3 right, 4 down. So you go 1, 2, 3 right, and then you do 1, 2, 3, 4 down. So this thing here is now sent here. So the graph for y equals to negative square root of x minus 3 minus 4 would be this thing. Okay. So that's how you use transformation to draw complex functions. Okay, question 3. F of x is a piecewise function, and because you have to graph this anyways, let's try to draw the graph. Well, okay, let's try f of 0 first. F of 0. F of 0 is 0 less or equal to negative 1? That's not true. So this is not true for 0. However, 0 is bigger than negative 1. Therefore, we should be following x minus 1 in order to evaluate f of 0. So this one would be 0 minus 1. In other words, you plug in 0 here, which is negative 1. On the other hand, if you look for f of negative 3, that's negative 3 is less than negative 1, so you have to follow this formula here, which is negative 2 times negative 3 plus 3, which is positive 6 plus 3, which is 9. Okay, now technically you can draw the graph by just plugging in a bunch of values and making a table. But if you do it that way, you can certainly do it that way. You have to be careful because the graph might have discontinuity at negative 1. It might have like, the graph might be like something like you have some graph here, but suddenly there's a jump at negative 1. So that could happen because this is piecewise defined function. So whenever you make a table and draw a graph, a lot of people have the tendency to just plot a bunch of points and then connect all of them into a single line. But you can't do that at negative 1. You have to be very careful at negative 1 because it's possible that the graph is not connected. Actually, you can figure out whether you have a jump or not, and the way you do it is by plugging in this negative 1 in both of them. So if you plug in negative 1, that's 2 plus 3, so f of negative 1 is 5 because you plug it in here. But if you plug in negative 1, which is not f of negative 1, but nonetheless you can still plug in and see what that gives you, that's negative 2. So what actually happens is that this negative 1 comma 5 is the actual value of the function, so that's a closed circle. Whereas negative 1 comma negative 2 will be an open circle. Okay, and as long as you draw the graph from negative infinity to negative 1, and then negative 1 to positive infinity, make them separate and have this jump discontinuity, then it's fine. Okay, but let's do something a little more elaborate. We'll just draw these two separately and try to put them together. So first, y equals to negative 2x plus 3. What's that? You have a 3 as your y-intercept because this is mx plus b type, right? So this is y-intercept. M is your slope, that's negative 2. So rise is negative 2, run is 1. Because slope is rise over run, you can see, you can try to draw like this, so you get a graph that looks like this. Okay. And on the other hand, if you draw the graph of y equals to x minus 1, then the graph is like negative 1 is your y-intercept, and you don't have anything in front of x, but that means 1 times x, so your slope is 1. So you go up by 1, and you go right, rise is 1, run is 1, so this is your next point, so you end up with this graph. Now, it turns out that because this graph is only valid for before negative 1, when you put them together, here's what you have to think about. We're going to make the graph quite big. Here's this negative 1. Okay, this is negative 1. Now, on the right side of this graph, you're following this. So you draw this graph. And remember, negative 1 comma negative 2 is an open circle, so you put open circle here. And then negative 1 comma 5, okay, that's quite high. 3, 4, 5, right here. There's a closed circle. And then, see, the graph that I have here is this line, right? So you have this line, but it only shows this part of the line. So see, this side is going to be invisible because that's not part of the function. Okay, so you have this as the graph. So the answer to part C will be this. Okay, you have this line here, open thing like this. Okay, now I'll use this small plot of space to answer D. what is y equals to 1 minus x, f of 1 minus x? Well, to figure this out, you should first think about f of 1 plus x. Okay, if there's a minus in front of x, before considering that, try to think about the one with the plus. That really helps. What is this graph? Well, this is same as a f of x plus 1, right? So think this. And if you have f of x plus 1, I know that this makes it go left by one step. One by one. And then you now replace x by negative x. So x goes to negative x. Then you end up with y equals to f of negative x plus 1, which is same thing as what we have here. Negative x plus 1 is same as 1 minus x. Now f of negative x plus 1 is therefore some kind of reflection. To figure out exactly what kind of reflection it is, it's helpful to draw this small picture here. Here's x, here's negative x, here's y, here's negative y. And let me put y over here, y and negative y. And if you go from x to negative x, if x goes to negative x, what did you do? You flipped over the y-axis, right? So this is really reflection over the y-axis. That's what this is. It's a reflection over the y-axis. So in other words, this y equals to f of 1 minus x can be thought as composition of two transformations, which is you first take this graph, just make it all shift one to the left, and then you flip this upside down. Okay, that's a little challenging, but let's try it. So if you first move everything to the left, you're gonna, instead of having something at negative 1, you're gonna get negative 2 here, and negative 2 you're gonna get this boundary where the graph would be now. See, if you move this point is 1, 0, so if you move it, that's gonna go to 0, 0, right? And this point here, open circle, was at negative 1, negative 2, and now that's going to be at negative 2, negative 2. So there's an open circle at negative 2, negative 2, and it passes through the origin, and that's the graph you get. And that negative 1, 5 will be shifted to negative 2, 5. So here's let's say this is 5, negative 2, this is negative 2, negative 2, 5, and there's this line. So that's the graph of y equals to f of x plus 1. Now finally, to answer this, you have to flip this upside down. And I don't have any more room, so let me just erase a few graphs here. I'll erase this part. Okay, I'll erase this. Okay, now I'm just going to draw the final answer here, which is, again, you're going to get some boundary at negative 2. And see, this point here was negative 2, negative 2. And if you flip upside down, the y-coordinate changes. So this will go up till negative 2, positive 2, right? So what was here now goes up here, which is positive 2. The origin, if you flip upside down, the origin doesn't flip, so it stays there. So it's still the same thing. Connect. So that's this part of the graph. Now that one, which was at negative 2, 5, if you flip, y-coordinate switches, so that's negative 2, negative 5. So 1, 2, 3, 4, 5. Here's negative 5. Negative 5. And there's a closed circle here, and what went up now should be turned upside down, so it will go down. Okay, so that's the graph of y equals to f of 1 minus x, which is the answer for D. Okay, given f of x 5x minus 5 and g of x 2x squared plus 1, find f of g of 2. Okay, the first question is about this circle thing. That circle is actually a composition. Anytime you see that circle, don't think about anything. Just replace the formula by taking this circle, breaking them into two, and if you break a circle into two, what do you get? You get two half circles, and that becomes your parenthesis, okay? Just imagine yourself breaking this, cutting this circle in half, like that, and breaking it to two parentheses, and this is what you get, okay? This thing is called composition, and all it is saying is it's asking you to calculate this. Now, when you calculate f and g of 2, you just want to start from inside and go out, okay? So what's g of 2? Well, g of 2, according to this formula here, is 2 times 2 squared plus 1. That is 2 squared is 4, 4 times 2 is 8, 8 plus 1 is 9. So you can replace g of 2, since it's same as 9, you can replace g of 2 by 9. What's f of 9? Well, you're computing with using this formula, so it's 5 times 9 minus 5. 5 times 9 is 45 minus 5, that's going to be 40. Okay, I need more room, so let me do b here. b f over g of negative 2. Again, it's just same kind of question. You just have to rewrite what this means. This just means you're taking the ratio of two functions. Okay, so this is the definition of this symbol. See, these are just symbols. F over g, f circle g. Sometimes you might have f plus g. You can also have f minus g, f times g. All of these symbols have just the obvious meanings, except for this circle. This circle, you have to remember that you should turn that into two parentheses, a pair of parentheses. But these just have the obvious meanings. So for example, f plus g of x means just f of x plus g of x. Yeah. Those are the definitions, okay? And once you write the definitions, then you can try to calculate them. What's f of negative 2? That's like plugging in negative 2 into the function f. So that's what you have to compute. What's g of negative 2? That's plugging in negative 2 into the function g. So it's 2 times negative 2 squared plus 1. 5 times negative 2 is negative 10, negative 5, negative 15. Negative 2 squared is 4, 4 times 2 is 8, 8 plus 1 is 9. Try to reduce your answer to the lowest term. They're both divisible by 3, so it's negative 5 over 3. Now in part C, it's asking for f circle g of x. Again, don't think about anything, just first rewrite it as f parenthesis g of x. And then you think about what this means. Well, this means f of g of x. What is g of x? G of x is this entire thing. So you replace g of x by 2x squared plus 1. And here comes the first challenge of this question. How do you plug in 2x squared plus 1, which seems like really complicated, into this definition? Well, to do that, I recommend using two-step procedure, because so many people screw up this process when they're asked to calculate f of negative 2. They have no problem at all, but suddenly when they're asked to calculate f of 2x squared plus 1, they just don't know what to do. So I advise you to use this two-step process, and only just go ahead and write the answer only if you are really comfortable with this. Unless you're really good at math, try this two-step process. Okay. So what's step 1? Step 1 is to just rewrite this definition, the function, rewrite the function. But anytime you see an x, you're going to put some parentheses. Okay. So you're going to replace x by blank spaces. Okay. That's step 1. What's step 2? Step 2, you put in this 2x squared plus 1, or whatever you're trying to plug in, into all the blank spaces that you see. So in other words, you have 2x squared plus 1 here, and 2x squared plus 1. Okay, that's the two-step process. Once you do that, then afterwards you just compute whatever you're given. Okay, so 5 times 2x squared plus 1 would be 10x squared. 5 times 1 is 5. Subtract 5. 5 cancels, and you get 10x squared. Okay, D is a similar question. You have g of x plus h minus g of x. And really the challenge is what is g of x plus h? So let's go here. Let's go here and try to rewrite that. So g of x is this. What is g of x plus h? And do not go ahead and write x plus h here. Do not write x plus h. What you're going to do is you're just going to copy this definition, except that anytime you see an x, you're going to put blank parentheses. Okay. So that's step 1. And then in the second step, because we're looking for what x plus h is, then you're going to write down x plus h into those blank spaces. Now, you need to simplify this because it's asking you to simplify it. What you need to do is you have to FOIL this out. What's x plus h squared? Let's see. That's x plus h times x plus h. So you have x times x, that's x squared. X times h, that's xh. H times x, that's hx. H times h is h squared. But see, xh and hx are the same thing because multiplication is commutative. It's like 5 times 3 is 3 times 5. So I can rewrite this as xh, and if you do that, you end up with xh plus xh, that's 2 times xh plus h squared. Knowing this, now you can rewrite this as what we just figured out. Add 1, and that's 2x squared plus 4xh plus 2h squared plus 1. Okay, and that's what I'm going to replace g of x plus h by. This g of x plus h is 2x squared plus 4xh plus 2h squared plus 1. Minus, and here's another place a lot of people make mistakes. See, you're replacing g of x by 2x squared plus 1, but minus is in front. If you have a minus or any other number in front of that, what you're trying to replace, be sure to put a parenthesis, because without the parenthesis, then this minus wouldn't be distributed properly. You put a parenthesis, and in there, I put 2x squared plus 1. Okay. So many math mistakes can be avoided by putting parentheses, just like how we put parentheses here. People forget to put that parenthesis thinking it's not a big deal. You end up costing yourself a lot of points. So please don't do that, okay? 2x squared plus 4xh plus 2h squared plus 1 minus 2x squared minus 1 after distributing the minus. And I see that 2x squared and 2x squared cancels. And then 1 plus 1 and minus 1 cancels. So what's left? You're left with 4xh plus 2h squared. So that's the answer to D. Question 5. F of 1 is 2, f of 2 is 4, f of 3 is negative 1, f of 4 is 1. Find f(f)(1). Simple question. Do not think about what this means. Just replace this single circle as pair of parentheses and then put that f1 inside. That's all you need to do. That's the first step. Without doing this first step, you won't be able to solve this problem. Now, what is f of 1? That's 2. What's f of 2? That's, according to here, that's 4. That's it. Very simple. Okay, the graph of fx and gx are shown below. Use the graph to find f composed with g of 3 and g composed of f with 3. And then find the domain of g circle fx. Okay, I sometimes read this as circle, but it's really a composition of two functions. So let's start with f composed g of 3. That's just f parenthesis g of 3. What's g of 3? G of 3 is where 1, 2, 3. It's here. You go up here and you see that the graph has, let's see, 1, 2, 3, 4. So that's 4. So we know that this is f of 4. G of 3 is 4. Well, what's f of 4? This is the graph of f. 1, 2, 3, 4. That's 4. If you go up, you see that it's at 2. So that's f of 4 is 2. So this is 2. On the other hand, what's G circle F? This composition is actually not commutative, so you might think, aren't these the same thing? Actually, it's not. We'll see that by doing this question. G circle F3, first step, always change that into a pair of parentheses. And then f of 3 is what? F of 3, 1, 2, 3. It's passing right over the x-axis, so that's 0. So it's asking for g of 0. f3 is 0, therefore if I replace f3 by 0, you get g of 0, and g of 0 is right here. At over 0, this is this point. And the height of this point is the value of the function, which is 1. Okay, now find the domain of G circle F. That's tricky. But again, write it like this and then you're going to think. Okay, here's the question. The domain is the allowed values of X, right? The values that are allowed to be plugged into X. See, basically what you're trying to do is think of functions as machines where you have some input and it gives you output. Now there are some illegal inputs. Illegal inputs are where if you put it into the function says, I'm not defined for that input. Okay, and function gives out undefined. Okay, so excluding the illegal values, what are the legal values that you're allowed to plug into the function? That's basically the question. Now for the function f of x, I know that values between 0 until, let's see, that's 3, 4, 5, 6. So fx has the domain 0 until 6. Any value that's between here, you're allowed to plug in. However, this output, just like here when we had the f of 3 as 0, the output is going to be plugged into G, right? And it will evaluate something. Now here it was okay. G circle F3 was definitely okay because it gave us an output. But think about this. If you, say, try to plug in 6, then you see there's some problem there because f of 6 is what? That's way over here. That's 2, 3, 4, 5, 6. That's 6. F of 6 is 6. So you have to evaluate g of 6 now. So suppose you're trying to do g of f of 6, which is g f of 6. And because this is 6, you have to do g of 6. But then you're in trouble because when you go to 6 and look for the graph of g, of g doesn't pass over 6 or under 6. There's no portion of the graph passing over 6 or under 6. Therefore, there is no g of 6. So this is undefined. In other words, even though it was okay to plug in 6 into f, it's not okay to plug into this composed function because after the first step, in the second step when you have to calculate the g, it becomes undefined. So 6 is not part of the domain. So what's the domain of G circle F? What is this? Well, we see that your value that f produces has to be allowed to be plugged into G, right? So therefore, you need to think about what the domain of G is. Now let's look at the graph of G. It extends from what? 1, 2, 3, 4, negative 4. So negative 4 all the way up till here is positive 4, right? So 1, 2, 3, 4. So the G of x has the domain from negative 4 until positive 4. So if some value of the function becomes below 4 or over 4, then you're in trouble. Okay. Fortunately, f doesn't ever produce any value below negative 4. The lowest it produces is negative 2, so we don't have to worry about this. However, it does go up beyond 4, look here, this is 4, right? So at 5, f of 5 gives you 4, but afterwards it's illegal for it to be plugged into G. So you see that out of the possible inputs into f, 0 through 5 is okay because it's still inside, the output of the function f is still inside this domain, but after 5 it becomes illegal. Therefore the domain of this would be 0 to 5. Okay? Yeah, it was a little confusing, so if you didn't catch this, I advise you to rewind a little bit and follow this reasoning slowly again, and hopefully by then you'll be able to understand. Question 7. Okay, you're given a quadratic function and you have to rewrite in vertex form, and you have to figure out where the vertex is, the max or min, and you have to find the intercept, sketch the graph, and so on and so on. Okay, so let's try that. First, what is a vertex form? Vertex form is y equals to a times x minus h squared plus k. That's called a vertex form. This one here, it's ax squared plus bx plus c. That's called the standard form. Okay, and I guess there's one more form that's quite handy in quadratic functions. That's the x-intercept form. Intercept form. And that case is y equals to a times x minus x1 and x minus x2, where x1 and x2 are two intercepts. Now, if you have an intercept form, you can always expand this to make it into a standard form. And if you have a standard form, you can always change it into vertex form by doing this completing the square business. Now, I know that a lot of you have trouble doing the completing the square. So often, instead of doing the completing the square, we're going to take a shortcut and do the following. We will just know that this a and this a is the same, and h comma k is the vertex for the vertex form. Alright, and actually that's enough, so you can kind of skip the process of completing the square and go straight to the vertex form just by finding the vertex. But to find the vertex, you need the vertex formula. So what is the vertex formula? This is negative b over 2a. And actually this gives you the x-coordinate of the vertex. So if you want the y-coordinate as well, which is the case, we need the y-coordinate of the vertex also. In that case, you have to plug in the x-coordinate into the function again to figure out exactly what's the y-coordinate. Now, let me just quickly explain where this vertex formula comes from. You have to recall the quadratic formula. This is a quadratic formula, right? And this means there's this negative b over 2a plus minus square root of b squared minus 4ac over 2a. You can take this single fraction and make it into two fractions just like this, right? And I don't really care what this value is. It's some really hard value, some really hard value, complicated value. But all I'm trying to say is that there's some value, and the two roots are this plus that value and this minus that value. So it's like this. You have negative b over 2a, and one x-intercept is this plus something, and another one is this minus something, so that this is like the midpoint between the two roots. And if you look at the graph of a parabola, then the vertex is right in the middle of the two roots, right? Two x-intercepts. If you take the midpoint, that's where the vertex is right at. So if you suddenly forgot the vertex formula in the exam, you just have to go back and think about this quadratic formula and just completely erase this complicated part. Then what you're left with is this vertex formula. Okay, so that's, hopefully you're not going to forget this because I explained it. Okay, all right, so you have the vertex formula negative b over 2a, and let's apply it here. A is negative 3, b is 12, so negative b over 2a is negative 12 over 2 times negative 3. And that's negative 12 over negative 6. Negative negative becomes positive. 12 over 6 is 2. And that's your x coordinate. That's your h. So your h comma k, the h value is 2. Once you get that h value 2, now we're going to plug that into the function f of 2. And that's negative 3, 2 squared plus 12 times 2 minus 9. And that's 4 times 3, negative 12 plus 24 minus 9, that will be positive 3. So we know that h comma k is 2 comma 3. And therefore the vertex formula will be a is negative 3, same as before. X minus h, so it's x minus 2 squared, and then plus k, k is 3. That's the answer to part A. Alright, now you might say, well, this seems complicated. Is there any easier way? Well, hopefully you'll have to understand that this is the easiest way possible. Let me show you how to do this in by using complete the square. It's often more complicated, and I don't advise you doing it, but you know, some people will like it. So let me show you how to do it using completing the square. So let's see. What you do is first you factor a negative 3 out, and you include the midpoints. So you have minus 4x. And the last one you don't include. Okay, so that's step 1. You have to factor the coefficient a out. And then what you do is you take the half of this middle number, the coefficient of x, the half of that number, and that goes inside the square. So it's x minus 2. Half of negative 4 is negative 2. So take that negative 2, put it inside the square. And then you have to ask, well, if I were to make this same as that, I better not have any constant term, right? It's like plus x squared minus 4x plus 0 is what you have here, right? I better have 0. But if you expand this, you're going to have x squared, and of course you're going to have negative 2 squared is positive 4. You also have the product of this, and you double it. That's how you get negative 4x. If you expand this, you're going to see that you get x squared, you get negative 4x, but also you get negative 2 squared, which is, what's negative 2 squared? That's positive 4, right? So you're going to get positive 4. But positive 4 is not good because you're not supposed to have any constant terms. So you have to say, I'm going to add negative 4, because if you do negative 4 plus positive 4, that they cancel to give you 0. And that's... by that, you can now say this is still equals to f. F of x is still this. Okay, and finally what you have to do, you have to multiply these two, and you get negative 3x minus 2 squared. Negative 3 times negative 4 is positive 12 minus 9. So you get negative 3x minus 2 squared plus 3, which is exactly same as the previous answer we had. And, well, it is a little confusing. Try it yourself. If you really want to try this, I advise you to turn this video off, copy the question down, and try to do it on your own, see if you can do it. Now, this seemed to be a little easier than usual because this number happened to be even integer. But in many cases, you're not going to get an even integer. You might end up with like a odd number or some fraction, so that if you take half of it, you end up with a fraction, and it becomes even harder. Alright, so that's why I don't advise you doing that, and in most cases using the vertex formula is a lot easier. Okay, now let's go to the next one. Oh, we already found the vertex. Vertex is what was 2, 3, right? Is the vertex a maximum or a minimum? Well, this -3 in front of x squared says the graph is like upside down parabola, right? If this was if you had +3, then you would have had a parabola opening up, but because this is negative, it's a parabola opening down. When the graph is opening down, the vertex is the highest point of the graph, right? So it's the highest, and therefore it's a maximum. Okay, so explain your reasoning. You have to say, since coefficient of x squared is -3, graph opens down. Okay, it's the graph opening down, and vertex is maximum. Okay. All right. Find the intercepts. Okay, what are the intercepts? Well, the simplest one is finding y-intercept. Y-intercept, you set x equal to 0, so you get f of 0 equals to 0 plus 0 minus 9. So all of these become 0, right? So you end up with -9. Okay, erase some stuff here. Okay, and then for the x-intercept, you have to set y as 0. Although there's no y here, think about fx as y, right? Y is fx. So putting y as 0, you end up with 0 equals to -3x squared plus 12x minus 9. I would divide everything by -3 there, because everything is divisible by -3. That will make things a lot easier. So you end up with -3 over -3 is just, they just cancel. 12 divided by -3 is -4, and then -9 divided by -3 is +3, and I know this can be factored as x minus 1, x minus 3, right? -1 times -3 is +3, -1 plus -3 is -4. So this factors like that, and that means either x minus 1 is 0, which means x is 1, or x minus 3 is 0, which is x equal to 3. So those are the two intercepts. Now, if you are just asked for intercepts, this might be fine, but a lot of times you might be asked to write your intercepts in ordered pairs. So you need the x and y coordinates, so the intercepts are following. You get 0, -9, that's your y-intercept. X-intercept is 1, 0. See, when x is 1, y is 0, so it's 1, 0, and then 3, 0, when x is 3. Okay, now we have to draw the graph. Let's just draw the graph here. I know that the y-intercept is -9, so let's put it here. And then there's a 1 here, and then 3 there. Those are the two x-intercepts. Okay, so here's y-intercept, x-intercept, x-intercept, and we also have 2, 3. That's the vertex, right? We already figured that out. So just connect this as a parabola and make sure your vertex is at the highest point, and that's the graph. Okay. Oh, another similar problem. Rewrite in vertex form. Okay. This one, it's a challenge to do this using the quadratic, completing the square. So we will not do the completing the square. We'll just do the -b over 2a thing, and in our case it's negative b is 7, a is 2, so -7 over 4. Alright, so that's quite ugly, and we have to plug that into the function to get the k value. So remember, in the vertex form, which is ax minus h squared plus k, where h comma k is the vertex, this just gives you the h value. And to get the k value, you actually have to evaluate the function at that 7 over 4. And that's a whole mess. You have to square this, plus 7, -7 over 4, minus 4. What's that? That's 49 over 16. 49 times 2 is 98 over 16. And let's see, that's 49, and it's minus 49 over 4 minus 4. And then you should multiply top and bottom by 4 so that you have common denominator. So, and also 4 is 64 over 16. So I want to make everything under 16. No, everything over 16. So 16 will be the common denominator. This is just 98. And if you multiply by 4, this becomes 196. And this becomes 64. Okay, what's that? That's 98. So you end up with 98 plus 64 to 162 with a minus sign. Okay, so that becomes a negative 162 over 16. Oh, I should have, you know what? I should have reduced this as 49 over 8. Then it would have been easier because you have everything over 8. But this is good enough. Okay, so we're going to reduce top and bottom by 2. So this becomes 81. And the bottom becomes 8. Okay, so that's your k value. And then all you have to do is, since a is the same thing as the a in the standard form, all you have to do now is to plug these values into the vertex form. So vertex form will be f of x equal to twice of x minus negative 7 over 4 squared. Be careful, there's a minus there, so you have to put a minus there. Okay, so x minus negative 7 over 4 squared. And you have plus k, and that's negative 81 over 8. Right? Let's simplify a bit. Negative negative is positive, so you have to put 2 times x plus 7 over 4 squared, and then minus 81 over 8. Okay, so that's the vertex form. And our vertex was negative 7 over 4, comma, negative 81 over 8. So that's the answer to part B. It says asking for the vertex. And because this time x squared is positive, the graph will be opening up and the vertex will be a minimum. So this will be a minimum because graph opens up to x squared. Okay, the 2x squared says the graph opens up. Okay. All right, now let's find the intercepts. Intercepts, you set, so for the y-intercept, you set x as 0. So you have f of 0, which is, you put 0, and then 0 minus 4. That's negative 4. And then x-intercept, set y as 0, and then you have 0 equals to 2x squared plus 7x minus 4. You could opt to use the quadratic formula, and hopefully you remember the quadratic formula, negative b plus minus square root of b squared minus 4ac over 2a. But another nice technique is, because often this gives you a huge, humongous value, often the nice technique is to factor by grouping. The way you factor by grouping is you multiply the first and last, and 2 times negative 4 gives you negative 8, right? This will be the product of two numbers that you want. So I want two numbers that multiply to negative 8 and add to positive 7. Well, I think 8 times negative 1 is negative 8, and 8 plus negative 1 is, a plus b, a plus b should be 7, so 8 plus negative 1 is 7. Okay, let me repeat myself. You multiply the first and last, and whatever number that you get, you want two numbers that multiply to that number you just multiplied, and two numbers that add. It has to be a plus b, that add to this middle number, the coefficient of x. And I see that 8 times negative 1 is negative 8, and 8 plus negative 1 is positive 7. And therefore, when you get those two numbers, 8 and negative 1, you're going to express this 7 as 8 plus negative 1, 8 plus negative 1, you expand this, x times 8 and x times negative 1, so you get 0 equals to 2x squared plus 8x minus x minus 4, and then what you do is you factor by grouping. Now when you factor by grouping, if x has a negative, you have to include that. Factor by grouping means you just factor these groups separately as much as possible. I see that they both have x as a factor and 2 is also a factor, so I factor out a 2x. If I take away 2x from 2x squared, x is left, because x times 2x is 2x squared, right? Then 2x times 4 is 8x, so this thing is same as 2x times x plus 4. Here, I need to factor the negative if there's a negative there, so negative is factored out, and you get x plus 4. Now once you do that, then immediately, if you did everything properly, then immediately you're going to see that this x plus 4, or something like that will be common in both terms. So I can factor that out. If I factor that out, x plus 4 is factored out, then what's left is 2x minus 1 and x plus 4. So you end up with the two intercepts being 2x minus 1 equal to 0. 2x is 1, so x must be 1/2. X plus 4 equal to 0 would give you x equals to negative 4. Okay, so the intercepts are, this one will be 0, comma, negative 4, and this is 1/2, comma, 0, and negative 4, comma, 0. So those are the 3 points. Okay, sketch the graph. Sketch the graph. Let's see. How do you draw the graph? You have to plot first the intercepts. Y-intercepts is 0, comma, negative 4. Here's negative 4. And then there's negative 4, comma, 0. So here's negative 4, comma, 0. That's x-intercept. And 1/2, comma, 0. It's just somewhere here. Let's say this is 1, this is 1/2. Okay, so you need to pass through these 3 points. I also know the vertex. What was the vertex? It was negative 7 over 4. What's this? This is like negative 1.75, right? Comma something. Something like negative 10, right? 80 divided by 8 is 10, right? Okay, so it's like negative 1 closer to here, somewhere here, and then it's way down here. Negative, something like negative 10. Okay, so this point here is negative 7 over 4, comma, negative 81 over 8. That's what we figured out. And then you pass these 4 points. That's the graph. Make sure that this is the vertex. Okay, so that's the graph. Okay, find the domain and range of f of x. I think I might have skipped this. Yeah, okay, so yeah, I forgot to do that for question 7, so let me do that for question 8, and I'll address the same question in question 7. Okay, question 8, find the domain and the range of f of x. Well, domain is all reals because there is no problem with having, I mean, if you had the square root, or if you had like a fraction that has denominator, then you would have a problem, but here there's nothing like that. For polynomials, the domain is all reals. So domain is negative infinity to infinity. That's always the case for quadratic functions. Now, but for the range is about the height, right? Height of this function, it goes up all the way to infinity. So going to infinity, that's not a problem, but it doesn't go to negative infinity because it stops at negative 81 over 8. That's the least it goes. So the range is, the least value is negative 81 over 8, and you put square bracket because it does attain that value, and the max value is infinity. So that's the domain and range. Alright, let me go back to 7 because I forgot that. Okay, what's the domain and range of this graph? Well, again, we're trying to answer question E. again, the domain is all reals. And then the range, well, it can go down to negative infinity, but it can go only up till 3, because 3 is the vertex. So range goes from negative infinity up till 3. Okay. And often, for the domain, you can just figure out the domain by just looking at the function, but for the range, you have to draw the graph. So asking for range is often the harder question. Okay, question 9. Does the relation x plus y squared equals to 3 define y as a function of x? Does the relation x plus y squared equals to 3 define y as a function of x? Well, there are multiple ways to do this. I guess the simple way to do this is like plugging in a value for x. Just so say x is 0. Okay. Let's see what y is. If I plug in 0, 0 plus y squared equal to 3, y squared is equal to 3, and you take the square root both sides. Remember, whenever you take the square root, you need plus 4 minus square root of 3. So for this single value of input x equal to 0, you got, what did you get? You get 2 outputs. In that case, that's invalid. So 2 y values invalid. Okay, a function may only produce one output for a single given input, so not a function. So that's one way to address A. Here's another way to address A. You can say x plus y squared equal to 3, subtract x both sides, and you take the square root both sides, you get plus or minus square root of 3 minus x. And once you do this, then you can say, well, this is not a function because for any single value of x, you have a plus value and a minus value. Again, there are 2 values, so it's not a function. Now, often the only way that people understand how to judge if a given relation is a function or not is by drawing the graph. The problem is this is not so easy to draw, but let me try to do it that way. So start from this, but switch x and y. So instead of x you have y, instead of y you have x. And then you subtract x squared, so it's 3 minus x squared. What is this? This is an upside down parabola with y-intercept 3, right? So it's like this. But this is not the graph that we're looking at. If you switch x and y, what's the graph that you get? You get y becomes x becomes y. And then the graph is flipped over y equal to x. You should probably remember that if you have x, negative x here, y, and negative y, then if you switch these two things around, then this rotates around this diagonal, right? So you end up with something that flips over the diagonal. Now, if you flip this over the diagonal, this fourth quadrant, this portion will go to the second quadrant because it's flipping over like that, right? So this portion goes like that. So you end up with something like this. And this something that's on the y-axis now becomes some point on the x-axis, and because that was a vertex, that will be again a vertex of parabola. And it's a sideways parabola. So that's the graph of x plus y squared equal to 3. Now once you draw the graph, then you can clearly see that this fails the vertical line test, and therefore it's not a function. So that'll be another way to explain. But since graphing this is not so easy, I guess you should just try to figure out how to do these. Alright, B. Actually, along the way, we were able to address part B, because if you have x squared plus y equals to 3, draw the graph. We already drew the graph. It's like this. It passes the vertical line test, right? Vertical line test. So yes, it's a function. Okay. C, again, you can just move the x squared to the other side. and then take the square root, and then let's immediately get plus or minus. So 2 values of y for a given x. So no, not a function. Okay. And for some people who already have seen a lot of pre-calculus materials, and you would know that this is a graph of a circle, right? It's actually a graph of a circle of radius radical 3. And if you knew that that's the graph, then this clearly fails the vertical line test. So you know that it cannot be a function. There will be another way to argue for it, okay? But I just wrote this down. Okay, number 10, residents of the town of Maple Grove who are connected to the municipal water supply are billed a fixed amount yearly plus a charge for each cubic foot of water used. A household using 1,000 cubic feet was billed $90, while one using 1,600 cubic feet was billed $105. What is the charge per cubic foot? Okay, and then write an equation, and then there's another question. Well, to solve this, you have to look closely and figure out that it's a fixed amount yearly, and then charge for each cubic foot. So let's say x is the cubic foot of water used. Then there's a fixed charge which we're going to call B. B is the fixed charge. And then the Y, the yearly bill, would be, Y would be, there's fixed charge plus X times some amount A per cubic foot. So A is the amount of charge per cubic foot. Okay, so that's the equation. What you should immediately recognize is that this just is a linear function. See, linear functions, they look like mx plus b, where b is the y-intercept and m is the slope. So this question is giving some information about this linear function, and then from this you have to figure out what that function is. When it comes to linear functions, there are two formulas that you absolutely need to remember. The first formula is the slope formula, which is slope equals to change of y over change of x. Well, if you have 2 points x1, y1 and x2, y2, then change of anything is always the final value minus the initial value. If you had like $100 today and then next week you're going to have $200, the change is plus 100. How do you get that 100? You subtract from 200 the 100. 200 minus 100. So the future value minus the previous value is the change of anything. So you have to do y2 minus y1 and then x2 minus x1 in order to find the changes of y and changes of y and x. Okay, so that's the first formula, and please try to remember this one rather than this, because this is a little confusing. You might just confuse yourself when trying to remember this. Just remembering this and remembering that change is simply final minus initial, that's a lot better way to remember this formula. Okay, so this is the first formula that you should never forget when doing linear functions. And the second formula you have to never forget is the point slope form. And then it's this form, y minus y1 equals to m times x minus x1, where x1, y1 is some given point on the graph. Okay, using these, you can figure out what this function is, because, see, a household using 1,000 cubic feet, so X is 1,000 here. X is the cubic foot of water used, right? And then the money charged, which is Y is 90. So this information can be encoded as 1,000, 90. Okay, and then this one, 1,600 is 105, so that can be encoded as 1,600, 105. So you're given 2 points on the graph, and using these slope formula and point slope form, you can figure out the function. And once you solve that and simplify, you can figure out what the function is. Okay. And once you have the function, then all of these questions are very straightforward. Okay, so let's try that. First, slope. See, you went from 1,000, 90, and then the next data was 1,600, 105. So the slope m is future value minus the current terminal minus initial. Okay, terminal value minus the initial value over the change of x, which is 1,600, terminal value minus the initial value. 105 minus 90 is 15. 1,600 minus 1,000 is 600. And then if you divide top and bottom by 50, you get 1 over 40. Okay, so that's your m, the slope. And then next is to use the point slope form, which is y minus, we're going to use x1 and y1 with as these. So y minus y1, which is 90, equals to 1 over 40 times x minus 1,000. Alright, so that's the formula for the line. Now I have to solve this in order to make it into this form. Okay, so let me just erase this part. And you have to remember that the y-intercept was the fixed amount of charge. The slope was the charge per cubic foot that we were talking about, and y is the actual charge. Okay, so our goal is to make it like that. Okay. So first I multiply 1 over 40 to both, so you have y minus 90 equals to 1 over 40 times x. 1,000 divided by 40 is 25, so you have minus 25, and then add 90 both sides, and that gives you y equals to 1 over 40 x plus this will be 65. Since I like fractions more than decimals, but since this is about money and it's the numbers here is about money, so it's better if you write it in terms of in terms of dollars or cents. So I want decimals in other words. So if you divide 1 by 4 is 0.25, 1 by 40 is 0.025. And now you see that 65 is the yearly basic charge, and for every cubic foot you're being charged 2.5 cents. Okay, so what's the charge per cubic foot is dollars 0.025. And that's the slope that you have. And B we are already done. F of x is this. That's the answer for B. And then part C, how many cubic feet of water would lead to a bill of 130? Okay, so when does this equal to the 130? That's basically the question. So in other words, when does this equal to 130? Well, let's just do a quick calculation here. If I subtract 65, you're going to get 1 over 40 x equals to 65, because 130 minus 65 is 65. Multiply both sides by 40 and you get x equals to 65 times 40, which is 2600. Am I right? 24, 20. Yeah, that's right. So the answer is 2,600 cubic feet. Okay, that's the answer for part C. Now, you have to check the reasonableness of this question. See, 1,000 cubic foot was 90, and 1,600 was 105. So 2,600 being 130. And it's kind of reasonable, so I like that answer. 11. Okay, another composition question. Compute f compose g of 4. Just take that circle, divide it into 2, and make that turn that into a pair of parentheses, and inside you get the g of 4. What's g of 4? G of 4 is 4 divided by 4 minus 2, which is 4 over 2, which is 2, right? So you're looking for f of 2, because g of 4 is 2. F of 2 is 2 times 2 minus 1, 2 minus 3, 4 minus 1, that's positive 3, 2 minus 3 is negative 1, so you have negative 3. Okay, so you have g of 4 is 2, and f compose g of 4 being negative 3. Okay, find and simplify f circle g of x. In other words, you're looking for f parenthesis g of x. That's what this means. And since g of x is x over x minus 2, we're looking for f of x over x minus 2. Okay, f of x over x minus 2. What is that? You're trying to plug in this complicated thing into f, which is already complicated. So you really need to be extra careful here. You want to copy the definition. We're doing the two-step process here. Two-step procedure, which is blank out all the x's. So any x's will be replaced by blank parenthesis. Blank. Okay, so all the x's switched out to blank. And then you're going to plug in whatever you're trying to plug in. Just write this x over x minus 2 and write that into all the blank spaces. Okay, so I plead you to use this two-step procedure, then you'll be alright. Okay. Now, it also says to simplify. So how do we simplify this? One slow way to do this is to make these two to be common denominators, this to be common denominators, and then you still have some complex fraction. Then you will need to do keep, change, flip. But let me show you a shortcut. The shortcut for simplifying this is just to simply look at the denominator, and if they're the same, just multiply that denominator once and for all. And the result is that when that gets multiplied, see, this gets distributed to the first one and the second one, right? When that gets multiplied to this first one, this denominator and what you're multiplying with will cancel each other, and you don't have any fraction anymore. And that simplifies things really quickly. Okay, so denominators are our enemy. We want to get rid of them. How? You multiply the top and bottom by the denominators. That's the key idea, right? So you have 2x, because x minus 2 canceled, but you still have to multiply x minus 2 to this negative 1, so you have minus x minus 2. Don't forget this parenthesis, very important. X minus 2 cancels, and you get x minus 3 times x minus 2. Okay, and then 2x minus x plus 2, when you get rid of the parenthesis, you get minus x plus 2. And then here, if you get rid of the parenthesis, this will be negative 3x plus 6. So x minus 3x plus 6. So you get x plus 2, negative 2x plus 6. Okay, so that's our composition, right? So this the answer to part B is that f composed with g of x is x plus 2 over negative 2x plus 6. Okay. Now, for what values is f of g of x not defined? Well, see, g is not defined. So for part C, we have to be careful here. G is not defined when? When x is 2. So x cannot be 2 because g of 2 is not defined. It's very important. Okay, so that's the first warning. And then there's another problem here. Sometimes this produces an illegal value, so when that is being plugged into f, that's going to be illegal, right? See, when you compose this, first the value is computed through g, and then the resulting value gets computed through f, right? Just like here, f of g of 4 is computed, whatever that value you get, you compute by f, and then that value gets computed, right? So if x is not 2, then of course g of x can be calculated, no problem. But what if that value turns out to be 3? 3 is a no-go for f of x, right? So you need to make sure that g of x cannot be 3. Also, g of x cannot be 3 because f of 3 is not defined. Okay, so let's see when this actually happens. G of x is x over x minus 2. When is this equal to 3? That's the question, right? So let's multiply by x minus 2 both sides. So multiply this to the other side, and you get x equal to 3 times x minus 2. So x is 3x minus 6. Subtract 3x both sides. So you get negative 2x equals to negative 6. Dividing by negative 2 both sides, you get x equals to positive 3. Okay, so when you plug in positive 3, let's see if you plug in positive 3, yeah, you do get 3, right? So positive 3 is illegal, and positive 2 is illegal. So the answer to C is, the answer is x equal to 2 and x equal to 3 are illegal values. Okay, those are the values where f of g of x is not defined. So that's the answer. Alright, I made a mistake in numbering, and I went from 11 to 13, so don't be alarmed. I'm not skipping over 12. In the practice exam sheet, I just simply don't have number 12. Okay, question 13. You have f of x as square root of 11 minus 2x, and find the domain of that function. Whenever you have a square root, remember 0 is okay because square root of 0 is 0. No, square root of 0 is 0. So there's no problem in computing the square root of a 0. But square root of a negative, illegal, because this gives you I, an imaginary number. Imaginary number. It's not really a number, okay? So when you have a square root and you want to find the domain, what you need to say is that I need whatever that's inside the square root, this has to be 0 or positive. Okay, and then we have to solve this. How do you solve it? You add 2x both sides, and then you get 11, and then divide by 2. So you get x less or equals to 11 over 2. What's that? In interval notation, x can be negative as much as you like, so it's negative infinity, but it can only go up to 11 over 2. So that's your domain for question A. What about question B? Well, whenever you have a fraction, x squared plus 3 over x squared minus 5x plus 4. It's this denominator that causes us the headache. If this ever becomes 0, then the g of x becomes undefined. So we want to figure out when the denominator equals to 0. Well, I can factor this. This is x minus 4 times x minus 1 equal to 0. So either x is 4 and x equal to 1, right? So what you see is that x can be anything, 1 or 4, that's okay, but you're not allowed to have 1 nor 4. Okay, everything except 1 or 4. The way you write this is, well, this is 1, 2, 3 intervals, so you just list those intervals, negative infinity up till 1, then 1 to 4, and 4 to infinity, and then you take the union of these intervals. A farmer with 2,400 meters of fencing wants to enclose a rectangular field that borders on a straight river. If the farmer does not fence the siding along the cliff, what's the largest area that can be enclosed? So viewed from the top, let's say this side is the cliff. And you have some fencing this way. Okay. And you want to the question is a little strange on a cliff. Okay, so let's say you want to fence 2,400 meters, and you want to fence like this, and you want to see the largest area that can be enclosed. Well, since it's going to be rectangular, if I call this x, this will also be x, right? And then this one is independent of x, so that should be y. And then you see that x plus y plus x is the fencing. Total fencing is 2,400. And what you want to do is you want to figure out whether the area can be maximum. So what's the formula for the area? Area is x times y, right? Now the goal is to use this to figure out a as a function of x. So what you want to do is you want to solve this for y. So this is y plus 2x equals to 2,400. So if you subtract 2x both sides, you end up with y equals to 2,400 minus 2x. Okay. All right. So you can say a is equal to a equals to x times 2,400 minus 2x, which is equal to 2,400x minus 2x squared. Okay, so what do we see? A is a function which is a quadratic function. And you're looking for the largest area, largest value of a. That's what we are looking for. Now, but we also know something about quadratic functions. See, if you rewrite this in standard form, it's like negative 2x squared plus 2,400x, and then plus 0. Okay, so this is a, b, and c. C is 0. And if a value is negative, we know that the graph is opening downwards, so that the vertex is where you get the maximums. In other words, once you recognize that this is asking for maximum of a quadratic function, then you immediately know that you're looking for the vertex. How do you find the vertex? It's negative b over 2a, right? So we're going to compute this. That's the x-coordinate of the vertex. Once you get the x value, you plug that into the function to find the y value, and that's the area value that we're looking for. Okay, so negative b over 2a. Our b is 2,400, and then our a is negative 2, so 2 times negative 2. Negative negative cancels. 2 times this is 4. 24 divided by 4 is 6, so you get 600. So we know that x value has to be 600 in order to maximize, and the area when x is 600 is you're plugging in. So I'm thinking of this as a function of x, okay? Function of x, and when you plug in 600 into x, well, that's 0, 0, and 6 times 24, that's 144. So 144, 0, 0, 0, 0. And then 36,000 times 2, that's 72,000. So you end up with 72,000 square meters. So that's the answer. Okay, graph of h of x is shown. Sketch the graph of h of 2 minus x plus 1, and then sketch graph of this. Okay. All right. Now, there is actually a shortcut, you might say, which is to see where this point goes. Okay. So, see, h of 0 is 0. That's what we see from here, right? So whatever that gives you 0 here, and whatever value that you get will be the new new origin. Okay, and then additionally you might find that h of -1 is 1 and h of 2 is 1, right? H of 2 is 1, h of -1 is 1. Okay, so using these three values you can actually make a table of this new function, and by doing it that way you can kind of figure out what the graph is, but it takes a little bit of thinking. So I'll show you how to do it this way, and if you don't like it, you can use the transformations. Alright, so first think about what I have to plug in here so you get h of 0. So for a, if I set x is 2, then you get y equals to h of 2 minus 2, that's h of 0, right? And then plus 1, and h of 0 is 0, so you get positive 1. So you can make a table saying that when x is 2, y is 1. Okay? And because that's related to here, which is like the vertex of the graph, this is actually the point where the graph will have a change. Okay? So that's where the graph will change direction. Okay? Now, what about h of -1? Well, if you plug in 3, 2 minus 3 is -1, right? So you can say when x is 3, y is h of 2 minus 3 plus 1, and I know that h of -1 is positive 1, 1 plus 1 is 2. So when x is 3, it's going to be positive 2. And then I need h of 2, that's when x is 0, right? If you plug in 0, x equal to 0 gives you y equal to h of 2 plus 1. H of 2 is 1. 1 plus 1 is again 2. So when at 0, it's 1. Okay, if you have this, then here's what you can do. You can plot those points. 1, 2, comma 1. Here's 2, comma 1. And then 3, comma 2. 3, comma 2. Here. And then 0, comma 1. No, 0, comma 2. Sorry, 0, comma 2. 0, comma 2, just like that. And then remember, these two will be a straight line. This two will be a straight line because they're made of straight lines. And this point right here is where there's a change in direction. Okay, so that's the graph that you're going to get if you use this shortcut. Okay. However, trying to figure out these numbers are not so straightforward. So let me show you a different way. The second method tries to figure out what happens to the graph as we apply a series of transformations. So you start with y equal to h of x, which is this, y equal to h of x. And here's a tip. If you see a minus in front of x, just put that as plus and then see what you have. So y equals to 2 plus h of 2 plus x plus 1. So think about going from here to this. Well, this is the same thing as h of x plus 2 plus 1, right? What is that? That's 2 steps left and 1 step up. It's a shifting of 2 steps left and 1 step up, right? So that's the transformation involved. And what does that give you? Well, 0, 0 will go 2 steps left and 1 step up. And the same graph will be produced, so it's going to be like that and like this. So the slope is a little more steeper this way than that, right? It's like slope is 1/2 here and slope is -1 here. Alright, so that's the graph of this. But then what do? Now from here to the next part, which is x is replaced by -x. That's according to this picture here. When you go from x to -x, that flips over the y-axis. So in other words, you're trying to flip the graph over or reflect the graph over this. So you just think about like turning the page. So you have this graph, you turn this page over there. Okay, not this way, but turning the page backwards. So this goes over here, and then this one you move it to the left side. So if you do that, then this point, which was -2, 1, will now become 2, 1, right? And this line will now become this line, and this line will become this. Okay. So that will be the graph of y equals to h of 2 minus x plus 1. This is actually the proper way to solve this question. The previous method I showed you was like a shortcut, and actually you would only be able to apply it when the graph that you're given is kind of simple. Okay, so hopefully you would also understand this transformation. Let's try to do the part B in the same way. The part B, so you kind of want to go from outside to in, so this -2 has to be handled first, and then these things should be handled later, okay? So first is this graph, then you want to think about y equals to -2h of x. Well, this is actually two things composed. Minus flips over the x-axis. It flips like that. And 2, it stretches. It's stretches graph up and down. And down. Okay. So you first have this graph flipped upside down, so it's like this, and then you think about this graph as drawn on a rubber pad, and then you stretch it this way and this way, so that now this becomes steeper and steeper. Okay, so let me just erase our previous points. So that's the graph after flipping over and then stretching. Now you apply this shifting. This will be moving 1 to the left and going down by -2. So you take this graph, you move 1 to the left, go down 1, 2. So that's your new point where the graph changes direction. So it's like this. Okay. So and it's really, I mean, if you were trying to draw this in a grid paper, you have to make sure that you take a closer look at the slope. This slope will be like +2. Rise over 1 should be +2, and this one should have -1. Okay. See, this slope is -1 and then +1/2, right? And once you stretch it up and down, the result is that their slopes will be doubled, so it will be -2 and +1, but then you flip it over, and that makes the slope change its sign. Okay, so when you draw this on the grid paper, make sure that you have your correct slope. All right, number 16, you have polynomials. Give the leading term of this function. Well, what is the leading term? You're assuming that you expand all this, and by the way, this is really tough to expand. Like, for example, x plus 1 to the 5th power. That's like x plus 1 times x plus 1 times x plus 1 times x plus 1 times x plus 1. And you have to do this like FOIL thing, and then you get like this will already become x squared plus 2x plus 1, and then when you multiply these two, you're going to get x squared plus x cubed plus 3x squared plus 3x plus 1, and then so on and so on. It becomes like really, really complicated. So trying to expand all this and then looking at the leading term, I mean, what's the leading term of this? This is x squared, right? If you multiply this much, this will be the highest order term is what we call the leading term. So if you expand this, if you had all the time in the world, you'll be able to expand this, and you look at the highest order term, and that will be the answer to A. However, you don't have that much time during the exam, so what you want to do is just look at what happens to the highest order in each case. So this one, when x is squared, you're going to produce x squared from this first one, right? This one will give you x to the 5th power, and this one will produce x squared. So if you multiply these, well, same base, the exponents add up, so you're going to get x to the 9th power. And there's no coefficient here, but afterwards you have -1/3 multiplied. So the leading term, the highest order term, when you expand this, it will be -1/3 x to the 9th power. Okay, so that's the answer to A. Find the intercepts of f of x. So how do you get intercepts? First, f of 0. F of 0 is negative 1/3, negative 2 squared, times 1 to the 5th, times 3. 3 cancels. Negative 2 squared is positive 4, negative 4. So the y-intercept is negative 4. And then you want to see when f of x equal to 0, that gives you the x-intercept. So when you have negative 1/3, x minus 2 squared, x plus 1 to the 5th, x squared plus 3 equal to 0. When you have a bunch of things multiplied to give you 0, each one of them has to, either the first, second, third, at least one of them has to be equal to 0. So that's what we're trying to figure out. Can negative 1/3 equal to 0? Well, that never happens, so here you don't get anything. Can x minus 2 equal to 0? Well, if you take the square root of both sides, you get x minus 2 equal to 0, and x is equal to 2. So we get a possible x-intercept. X-intercept is 2. And then can x plus 1 to the 5th power equal to 0? Well, you take the 5th root both sides, you get x plus 1 equal to 0, so x must be negative 1. So that's another x-intercept. Can x squared plus 3 equal to 0? Well, subtracting 3, you get x squared equal to negative 3. And you see that if you take the square root, well, you can't take the square root of negative numbers, so that's not a real number. So that's not a x-intercept. So the only x-intercepts are negative 1 and 2. So the answer to B, written in ordered pairs, it's 0, negative 4. That's your y-intercept. 2, 0, negative 1, 0. So that's the answer to B. Determine the end behavior of f of x. You should have learned in class that the leading term is what determines the end behavior. So if you have even leading term, then in that case you either have this or that. Not that, sorry, that's misleading. Your end behavior will be something like this or this, right? Well, this will be when your even leading term is positive, and this is when your even leading term is negative, right? Just think about parabolas. You know that parabolas open up when it's positive, and parabolas open down when it's negative. So that's what it says. Odd ones, however, they either have like that or like that. Okay, so this is a case when you have plus, this is when it's minus. It's also important to remember an example. For this, just remember y equal to x cubed graph, which is like that, right? So this certainly has this end behavior, and x cubed's coefficient is positive, right? Okay, so just by remembering this graph and some quadratic functions, you can easily remember this. In our case, it's the odd case, 9th power, and it's a minus case, so it's this one. So the answer to part C is this and this. You can just write this on the exam, okay? All right, and then sketch the graph of f of x, clearly labeling the intercepts. Okay. So your x-intercept is negative 4. No, sorry, y-intercept is negative 4. X-intercept is 2 and negative 1. Our end behavior is like this, this. Okay. So we come down here, and then you have to decide whether it passes through the x-intercept or not. And the important thing is, if the power for that is odd, then it passes through. If it's even, it bounces back. Okay. So since for x equal to negative 1, the responsible party is this factor x plus 1 to the 5th power, right? The responsible factor is x plus 1 to the 5th power. And since 5 is odd, it will pass through. So it passes through, and because it's some odd number bigger than 1, in that case, it kind of like touches. So if you magnify that, it goes like this. It goes like, it touches and then goes like that. Okay. If you simply had x plus 1 with no power, in that case, it just goes straight through. But if you have x plus 1 cubed or 5th power like that, then the graph will like touch it and go. Okay. So we know that it's going to be like this and goes down and touches negative 4. And then it'll start coming back. and then it will pass through 2. Well, at 2, the responsible factor is this one, and that has a square, right? So that means it will bounce back. So it has to bounce back, and it has to come down. Okay, so that's the graph. And as long as you make the graph pass through these 3 points, correctly make it pass through this -1 and bounce back at 2, and then somehow touch like that. That's all the feature I'll be looking for when I'm grading. So it's make sure that your graph looks somewhat like this. Find the possible formula for the quadratic function that satisfies 0 and 2 equal to 6. Okay, so let's try to draw the graph and see what it's saying. F of -1 is 0, so f of -1 is 0, so it's -1 comma 0, -1 comma 0. And f of 3 is 0, so it passes through 3 comma 0, so 1, 2, 3, 3 comma 0. And f of 2 is 6. F of 2, 1, 2 is some value way up here, 6. And then some graph. Okay, that's what I'm looking for. Okay, now remember we have 3 types, y equals to ax squared plus bx plus c. 3 types of quadratic function equations. That's the standard form, and then we also have a times x minus h squared plus k, which is the vertex form, and then y-intercept form is y equals to a x minus x1, x minus x2. Right? Now, of these 3, the best one to use is this x-intercept form because you're given the 2 x-intercepts. So you can think of this as x1 and that as x2 and plug that into this formula and say y is a times x minus -1, x minus 3. Okay, and then, so that's your function. That's your function. Y is f of x. And then the only thing that you have to do now, well, writing it this way automatically satisfies the first one. If you check, if you plug in -1, this will be 0, so this will be 0. If you plug in 3, 3 minus 3 is 0, so this will again be 0. So this condition was automatically satisfied if you write your function in this form. And then f of 2 equals to 6. That's the only thing that we haven't made use of. So you say 6 is f of 2, but according to this formula here, that's a times 2, that's plus 1, right? And then 2 minus 3, which is 3 times -1, so -3a. That's what you have. So 6 is -3a, so a must be -2. Plug that back into here, and the final answer is f of x equals to -2 x plus 1 times x minus 3. Here's another similar question. Find the formula for the quadratic function. It's given a vertex. Remember h comma k, that's the vertex, and y-intercept -4. Alright, so of the 3 formulas, we're going to use the vertex form with h being 1, k being 8, a is still unknown. A is still unknown. We need to figure out the value of a. That's your function of f of x. Okay. Now y-intercept is -4. In other words, 0, -4 is a point on the graph. So if you plug in 0, you have to plug in 0 into x to get the y-intercept, right? What's that? -1 squared is +1. So a plus 8 is what you get if you plugged in 0 here. But that value has to equal to -4 because that's how you can have the y-intercept, y equals to -4. Subtracting 8 both sides, we get -12, and therefore plugging that back in here, we get the function of x given as -12 x minus 1 squared plus 8. Alright, so as you can see, when you're given the information about the function, when you're given a quadratic function and you have to figure out the formula, often you need to make the right choice. I solved these questions rather quickly, but if you choose the wrong formula and try to do it, it'll take forever. Okay. Find the value of k so that the graph passes through point 0, -11. That's really easy. You plug in 0. And that has to equals the y value, which is -11. 5 squared is 25, plus k equals to -11. Subtract 25, that's -36. Plug it back in. Oh, well, it's just asking for the k value, so that's the answer. Find the formula for the parabola through these points. 4, 5 is vertex. Whenever you're given the vertex, you should always use the vertex form. And h is 4, k is 5, so you have f of x equals to 8 times x minus 4 squared plus 5. Now it also has to pass through 7, 9, which means the value of the function should be 9 when you plug in 7 for your x. So 7 minus 4 squared, that's 3 squared, which is 9. So you have 9a plus 5 equals to 9. Subtract 5, divide by 9. So 4 equals to 9a, and then divide by 9. You get a equals to 4 over 9. Plug that back into this, what you have. The answer is f of x is 4 over 9, x minus 4 squared plus 5. Alright, here's our last question. An empty champagne bottle is tossed from a hot air balloon. Its upward velocity is measured every second and recorded in the table below. Find the formula for the velocity of the bottle as a function of the time since the bottle is tossed. Okay, so you want v as a function of time, some function of time. But what you have to see is that if you look at this carefully, the difference is negative 32. So you subtract 32 every time, right? Negative 32, negative 32. You can check this. Yeah. I already checked this before making this video. That's how I know. But you can see that every second it goes down by 32. And it's not surprising because if you learned a little bit of physics, you would know that the gravity acceleration is 32 feet per square second. So at every second, a falling body without any kind of friction will be subject to negative 32 acceleration. Okay, so what does this mean? If you draw the graph starting from 38, then it's going to fall down to 6 and then fall down, and then the values are always the same. That means it's going to be a straight line. In other words, what you're seeing here is you're being asked for the function v, but function v is a linear function. And remember, when you're given a question about a linear function, you have to remember the two formulas, which is m equals to change of y over change of x, and then the point slope form y minus y1 equals m times x minus x1. Absolutely important, okay? So in our case, 0, 38 is one data point for t and v, and then the next one is 1, 6 is the next data point. So I'm going to call this t1 v1 and then t2 v2. Alright, we have to modify things a little bit because instead of y you have v, instead of x you have t. These formulas should be changed for v and t. So our slope will be like change of v over change of t, and this formula will be like v minus v1 equals to m times t minus t1. Okay, or another way to do this would be just write this as x1, y1, x2, y2, make a function of y as a function of x, and then replace, after you do everything, replace y by v and x by t. That will be another way to do it. Okay, so let's see. Terminal minus initial, that's how you find the change, right? 6 minus 38. If you do 38 minus 6, it's going to change the value, so be careful. Terminal minus initial, so you have 1 minus 0. So that's negative 32 over 1. So negative 32 is our slope. And then we're going to set t1 as 0 and v1 as 38. So if v minus 38 equals to negative 32 t minus 0. I'm using this formula with t1 as 0, v1 as 38, and m is negative 32. So we're almost there. We add 38 both sides, and we expand, and we get v equals to negative 32t plus 38. So now we have found velocity as a function of t. Now before we finish, let me just write down some formulas that you absolutely have to remember. So vertex x coordinate is h equals to negative b over 2a, right? And vertex form is vertex form y equals to a times x minus h squared plus k. The x-intercept form is y equals to a times x minus x1, x minus x2. And then there's a quadratic formula. You should never forget that. X equals to negative b plus minus square root b squared minus 4ac over 2a. Quadratic formula. And then that's all I can think of in terms of quadratic functions. For the linear functions, m is change of y over change of x, and the point slope form. Okay. And I guess that's it. These are the formulas that you should absolutely remember. And some more facts like pay attention to that polynomial graphs, that odd powers make something go through, even powers make it go bounce back. You also have to know that when a is positive, the quadratic function opens up. If a is negative, quadratic function opens down. Also the end behavior, you have to remember that. So those are the things that you have to remember, and without remembering those things, that you'll a lot of points will be at stake. Okay, I hope you can review this video one more time, or maybe 2-3 more times, and be ready for the exam. Okay. See you.